Hey guys, welcome to lesson 5.1. Today we're going to talk about very specific conditions or shortcuts that you can use to help you decide if two triangles are similar or not. We've been talking about similarity quite a bit, but now we're kind of really focusing in just on triangles and the specifics of them alone. So we have three shortcuts or conjectures, as we call them, to decide whether two triangles are similar or not. So the first one is called SSS, which in all of these, the S's all stand for side, and then the angles, the A all stand for angles. So SSS means side, side, side. Now it sounds funky, but it'll make sense once we explain it. The definition of side, side, side similarity is that we are able to find three equal corresponding side ratios. Okay, three equal corresponding side ratios. So what that means, and I'll use this example that I've included here to help us see what I mean, is we need to match the sides. Oops. We need to match the sides and make sure that when we make ratios out of all of those matched side pairs, that all the ratios are equal when we do the division. So I know that those sides match because they're the biggest. I know that these sides match because they're the smallest. And that leaves me with the middle pair. Alright, so now that I've matched all my sides, I can go ahead and make the ratios and see if they are equal. So now I can start with the blue one. Let's see, we can do 8 over 4. We can do the green one, which is 6 over 3. And then we have the red one, which is 4 over 2. Okay, so let's go ahead and actually do that division. It's really important that you guys understand that these are the ratios, and then when you actually divide them, those are still the ratio, but that's like the simplified version. So 8 divided by 4 is 2, 6 divided by 3 is also 2, and 4 divided by 2 is also 2. So because we got the same number for all of them, we have side, side, side similarity. And this is something that we've already talked about, right? That's not really anything new. We know that all the matching side ratios have to be equal whenever we have similar figures. Alright, moving on to SAS. Now, SAS stands for side, angle, side. Alright, so what side, angle, side means is that now we have two pairs of matching side ratios. It's because we have two S's. Every S stands for a pair of sides. So, two equal corresponding side ratios. And not just that, but we also have to take into consideration this A. That A means that the angle between those two sides is also equal. Now I'm underlining between because it has to be the angle between the two sides in question. It can't be in a different spot. Like this 60 is between the 5 and 6, and this 60 is also between like the same two matching sides. That's why it works. The 60 can't be anywhere else. Alright, so in this picture, let's go ahead and test it out. We know that here we have AB matches with DE, because they're in like the same spot, and then AC matches with DF. Okay, so now let's go ahead and set up the ratios and make sure that they're actually equal. So if we do the blue one, we have 10 over 5. 10 over 5 equals 2. So that's a start. And then for the red one, we have 12 over 6. And that also equals 2. And we already know that the angle condition is fulfilled because the 60-degree angle, if it was different numbers, then it would be an issue. But since 60 is indeed equal to 60, we have SAS similarity. Okay, and again, notice how the angle in question is smack dab in between the two sides that we're looking at. Like I said earlier, we can't have the 60 on this side because that would not be SAS. SAS means it literally goes in the order of side, angle, side. It has to be, the angle has to be sandwiched between the two sides. All right, last one, we have angle, angle. This is one that also isn't really too new to us. We already know that in similar figures, angles have to be preserved. So here, as long as we can find two pairs of equal angles, then we are similar. Now, the thing about this is that technically all three have to be equal, but we only need a minimum of two because if you guys remember what we learned about triangles some time back, all the angles in a triangle are going to equal 180. So if two of them are equal, the third one has no choice but to be equal because we already know that it has to add up to the same thing. So if these two angles added up to 150, then the third one has to be 30, right, to get it to 180. So if this triangle had the same situation where both of them add to 150, then again the remainder has to be the same, 30. All right. So let's go ahead and try some practice problems. All right, here I have 4 practice problems where we are going to decide whether or not each pair is similar. So we're going to decide if they're similar and we're going to explain why or why not. All right, for this first one, we have given 2 triangles with a bunch of side lengths. Now the first step with these problems is to just decide which of the conjectures it would make the most sense to test out based on the information we have. Like here, I have a bunch of side lengths. I have absolutely no information about the angles. So it would not make sense for me to try and test out SAS or AA because I don't have any angles. So we have to try SSS. That's our only hope here. So as usual, the first thing we want to do is match our sides. So the 21 goes with the 35 because they are the biggest sides in their respective triangles. The 10, oops. Alright, let's try that again. The 10 must go with the 20 because they are the smallest sides. And lastly, we have the 15 has to go with the 25 because that's all that's left. Okay, and again, remember that we are testing out to see if SSS is fulfilled or not. So let's start with setting up our ratios. So we have 35 over 21. We have 20 over 10. And we have 25 over 15. I'm just matching my colors pretty much. Okay, so here we actually want to go ahead and do the division. Okay, if we actually did 35 divided by 21 in our calculator, we would get an answer of 1.66667. So I'm going to call that 1.67. 20 over 10 is easy, that one's 2. And then this one, if we do that in our calculator, 25 divided by 15, we also get 1.66667. So this tells us, since they're not all equal, that these are not similar triangles. Okay, we needed all of them to be equal. Since 1.67 is not equal to 2, we are not similar. Alright, and that is an SSS example. If these were all 1.6667 or they were all 2, then they would have been similar, but they're not. Alright, number 2. Now, again, our first step is to see, okay, well, which conjecture should I even test out in the first place? And here, the biggest flag should be that there are no side lengths. We know absolutely nothing about the side lengths. So if you go here, it wouldn't make sense to choose anything that has an S in it, right? Because we don't know sides. So that leaves us with angle, angle. Let's test out angle, angle. So we look at these and we're like, okay, they obviously both share the 87-degree angle, so that's good. But then there could be a little bit confusion here. This 68 in this triangle does not match with the 25 in this one. So at a glance, you might look at that and be like, well, they can't be similar because there's not two pairs of angles. However, we do have an entire missing angle from both triangles, right? So we need to try and find that first before we can claim for sure that there isn't a second pair of matching angles, because who knows? This third angle could match one of these, right? So let's go ahead and find out what this angle is equal to. And we can do that because we know that all three angles of a triangle have to add up to 180. So if I did 180 minus all the other angles in there, that can give me what that angle is. That's just anytime you're trying to find what like a third angle is in a triangle, you just got to deduct the other ones from 180. All right. So now 180 minus 87 minus 68, if you do that in your calculator, we actually get an answer of 25. So this angle is 25 degrees. And so it actually worked out for us because this one's 25 and we know that this one was 25 as well. So we found two pairs of matching angles and therefore that's enough information to tell us that we are similar by AA. And without even doing any math, because we know they're similar, we know that the third angle must match as well. So this guy's going to be 68 degrees too. So we're going to say that we are similar by AA. Okay. Next we have this guy. This is honestly like the poster child for SAS in terms of which conjecture we should test out. There are two pairs of sides and an angle in between, so it's literally what you want SAS to look like. So these two have to go together because they're in like the same position. These two have to go together, these two sides right here. And then the angle is already done for us, luckily. We don't have to do any work. We already know because they both have the arc that those two angles match. So the A condition is already fulfilled. We just got to check the ratios. So we got the blue ratio, which is 44.8 over 14. And then we have the red ratio, which is 64 over 20. All right, so this is another situation where you want to bust out the calculator and do some division. If we do 44.8 divided by 14, we get 3.2. Oops. And if you're watching this video right now, I strongly suggest that you get your calculator out and do this with me so that you know what to do and you know that you're getting the same answers. If you do 64 over 20, you also happen to get 3.2. So because I have the two equal side ratios and I have the angle in between that's equal, we have SAS similarity. All right, one last example. This guy over here looks like we don't have much information, but we do have one crucial piece of information, which is that these two angles are equal because of those matching double arcs. Now, you might be wondering, man, what the heck conjecture should I test here? Well, there is no sides. There is absolutely no way for us to find out any information about the sides on these triangles, so that leaves us with no other choice but to test out AA. Okay? So here's the thing. We know that there's one pair of equal angles, and we need to see if there's another one. And this is where some of our old knowledge comes into play. Right off the bat, there's not really a lot you can do with this. However, if you notice this X, right? Anytime you notice an X, we know something about these angles, right? If you guys remember the kissing mice. So now we know that these two angles, whenever you make the X, these are vertical angles. And we know from some sections ago that vertical angles are congruent. So there it is. That's our second angle pair that we needed. So because we have one pair and another pair, red and green, we can say that they are similar by AA. Because we know that the two angles are equal, the third one would also be equal by default. All right, that's all for today.